Hello everyone and welcome back to the C++ 3D game tutorial series. In this 40 video tutorial, we will see how to render the text. In particular, we will see how to compile a font resource from a font installed in the system, how to render the text on the screen, and in the end, we will see how to anchor our texts to the screen bounds. As always, we will face three main parts: requirements, design, and implementation of all the necessary things to render the text. So let's start with the requirements. We need a C++ IDE. In this series we use Visual Studio 2019 Community. The target platform is Windows. The target graphics API is DirectX 11. And last but not least, a bit of knowledge of C++ programming language is recommended. Now we can start the design part. In this tutorial, we are going to see how to create and render the core element of the user interface, the text. The rendering of the text can be approached in many ways. Since we are using DirectX, we can render the text by exploiting a really useful library called DirectX Toolkit. That is a collection of helper classes for writing Direct3D 11 C++ code. In particular, we need two important classes, the sprite font and the sprite batch classes. The sprite font is a native Direct3D 11 implementation of a bitmap font renderer. In a few words, a bitmap font renderer allows to render text based on an image or bitmap that contains a set of glyphs and characters images. The DirectX Toolkit provides another important executable tool called MakeSpriteFont that, giving in inputs the name of a font installed in the system and other various parameters like font size and so on, the tool provides us as output the bitmap font like the one we can see on the screen. Last but not least, in order to effectively render these glyphs on the screen, we have to use the SpriteBatch class. SpriteBatch, as the name suggests, allows easily to render sprites and textures on the screen. In particular, SpriteFont exploits SpriteBatch in order to render specific glyphs and characters based on the bitmap font. That said, let's dive into the design of our class diagram. In the first place, we have to create the font2D class that is in charge to handle the SpriteFont and SpriteBatch classes instances. Since these classes are strictly related to the DirectX implementation, this resource should be handled by the render system. Then we have to handle the font2D resource in the resource manager by creating another high-level resource that we can call font. Another important class to implement is the font utility, in which we should manage the MakeSpriteFont tool mentioned previously. Last but not least, in order to easily allow the user to add text on the screen, we have to do nothing but create a text component class. Finally, as usual, we should handle the rendering of this type of component inside the update method of graphics engine class. In the end, we should obtain this final result. If you have questions, doubts, or comments about this topic, don't hesitate to leave them in the comment section of this video or in the Discord server. The link to the Discord server is available in the video description. Also, if you find these tutorials helpful, please consider to support their development on Patreon. Every single contribution makes the difference, regardless the amount. Very well, we have gathered all the necessary information to start the implementation. As first thing, let's go to the graphics folder and let's create the font2D class. At this point, let's add the constructor with the following parameters: the path of the font resource, and the reference to the render system. Let's fix a bit the C++ file. It's the time to use the sprite font and sprite batch classes mentioned in the introduction. To do that, let's go to the DirectX game project properties, and in the VC++ directories tab, let's edit the include directories field by adding the include folder of the DirectX toolkit. Let's do the same thing in the library directories field by adding the bin directory this time. Good, the next thing to do is to go to the linker and input tab, and we have to add in addition dependencies field the directx tkd.lib. Let's save everything. Cool, now let's add a unique pointer to the sprite font and sprite batch in the font2d class. Then, in the font2d constructor, let's finally instantiate the sprite font. Here we need the DirectX device that we can retrieve from the render system class. Let's remember to add a forward declaration to the font2d class in the prerequisites header file. And let's also make the font2d a friend class of render system. At this point, if the creation of the sprite font fails, let's throw an exception. Otherwise, let's instantiate the sprite batch class. In this case, we need the device context and let's retrieve it again from the render system. The next thing to do is to add an important method in the font2d class, that is, the getBounds method. This method should allow us to retrieve the boundaries of the text we want to render on the screen. This is really useful if we want to anchor our text at a specific points, corners, and so on. What else? Well, we have to create effectively the font2d resource. Let's do it in the render system class. And let's always remember to add the various declarations in the prerequisites header file. We can finally create the high-level font resource class, the one handled by the resource manager, in the resource folder. As usual, let's add the constructor by adding the following parameters: the path of the resource and a reference to the resource manager. Obviously, let's also add a reference to the graphics resource font2d as attribute. At this point in the constructor, let's finally create the font2d resource by using the render system. Let's also add a getter method for the font. We don't have to forget about the font utility class, in which we should manage the MakeSpriteFont executable tool. To do that, let's add a simple method called createFont. Here we should add the following parameters: the font name, the font size, and the output path in which the font file should be generated. In order to simplify a lot the string operations, let's use the so-called string stream object, in particular the wide version that allows to handle Unicode characters. Since font name could be potentially composed by space characters, let's use the regex replace function in order to delete all the empty spaces. In the end, let's compose our final output path. By using the file system exists function, we can check if a specific file exists or not. If the font file we want to create has not been created yet, let's create it. To do that, we have to use the MakeSpriteFont executable tool. In order to execute such tool, we have to send a specific command line to the terminal. We can do that by using the wide version of command function. It is possible to find a link to the documentation with all the parameters supported by MakeSpriteFont tool in the video description. So far, so good. What do we have to do now? We should handle the font created by the font utility in the Resource Manager. Let's remember to add a forward declaration to the font resource. We have finished the resource part. Now we can finally start to create the text component class in the entity folder. As usual, let's add the constructor and virtual destructor methods. Then, let's exploit the code we have just written in the light component. Let's remove the text component from the graphics engine during the destruction. And let's add it by creating the onCreateInternal method. At this point, we have to support this component inside the graphics engine, in the same way we have already done with all the other graphics components. As usual, let's remember to add the forward declaration of text component in the prerequisites header file. The first attributes to add in the text components are the wide string text and the font resource. Let's also add the correspondent setter and getter methods. As last thing, let's add the getBounce method. We have finally arrived to the main part. Let's go to the graphics engine C++ file and at the very bottom of the update method, let's start to implement the rendering of the text. For each text component, let's retrieve its position and its font. In order to access the private attributes of the font2d resource, let's make the graphics engine class a friend class of font2d. So the rendering can be accomplished by calling in the order the begin method of the sprite batch class, the drawString method of the sprite font class, when we call this method, we can decide what text to render, its position, its color, the rotation, and so on. For now, let's support the position. We will support the other functionalities in the next tutorials. In the end, we have to call the end method of the sprite batch class. We have finished. The only thing that we have to do is to use all these classes inside our myGame class. As first thing, let's include all the new classes in the all header file. Then, in my game C++ file, let's remove all the commented code that in this case is a bit useless. Let's finally start to add the text. The first thing to do is to create the font utility and compile the font resource. In this case, let's use the Banshrift font. If you don't have the Banshrift font installed in your system, you can use other fonts like Arial, Teroma, and so on. Then let's choose the font size, in this case 16, and last but not least, let's define the output path, that is, the assets fonts. Don't forget to create the folder fonts inside the assets folder before the execution of the game. Once the create font method is called, we should have a file with the font extension in the fonts folder. And so we can load it by calling the createResource from file method. Let's turn back a bit in the FontUD class because we have forgotten to call the get methods of the smart pointers. Let's finally debug our game. Let's check if there are issues. For example, here we have missed some characters in the command line. Pay attention to the spaces because those characters allow us to separate correctly the various parameters. Cool, the font has been compiled successfully. It's the turn to create the text entity. Let's set the font we have just loaded and let's also set a sample text like C++ 3D Game Tutorial Series. Let's also set the position and in the end let's see if it works. And it works! Unfortunately, we have some problems for these graphics artifacts appear because the state of the graphics pipeline has been changed by the spriteBatch and spriteFont classes. In order to avoid this issue, we have to clear the state of the pipeline at each game loop. To do that, let's go to the render system class and let's add a clear state method. Here let's call the clearState method of the immediate device context, and let's also clear the blend state as we have done in the previous tutorials. In the end, let's call this method in the update function. Here we go! What's next? Well, let's try to place this text at the center of the screen. To do that, we have to retrieve the display of our game by adding a getDisplay method in the game class. Let's also include the display class in the all-either file. At this point, in the onUpdate method of myGame class, we are to retrieve the size of our window, the boundaries of our text, and in the end we have to set the final position by using these values. Let's see if it works. And it works! Let's make the things a bit more complex and let's finally show some data on the screen. In particular, let's create a string stream object and let's add the FPS counter. In order to get the frames per second, we have to divide 1 by the delta time. Let's also show the width and height of the window. In the end, let's set the text inside the text component. Let's see what happens. It works! The text shows dynamically the amount of frames per second and the width and the height of the window. Let's add further data like the player position and rotation. And in the end, let's also add a copyright notice at the bottom right corner of the screen. That's all for now, folks. Today we have seen how to render the first element of the user interface, the text. The next time we will render the images. I hope you enjoyed this video. See you soon. Thanks for watching.